Hello, welcome once again to my channel. In this video, we are going to discuss the resultant of several concurrent forces. If this is your first time of viewing, consider subscribing to my channel. It gives you notification whenever a new video is uploaded. Okay, now, unlike the previous videos we've done under the resultant of forces, you observe that the forces we found their resultant are not like this, in the sense that they can only be two, but this time around you've seen that the forces are many inclined at so many angles to the horizontal. So in resolving this kind of vectors, you have to ensure that you use only the angle the force or the vector is inclining to the horizontal. For example, here you can see that this force is inclined at 60 degrees to the horizontal, this one is 30 degrees, this one is 40 degrees. One of these force here, so you should get the angle to which they are all inclined at the horizontal. Again, be careful whenever you're talking about the vertical component and the horizontal component. Make sure you consider their signs. The vertical component is talking about the y-axis, and the y-axis, whenever it falls on top here, it is positive. Anything below here is negative. For x-axis, towards the left is negative, then towards the right is positive. So if I like, I can still increase this. I can still increase this to see that this is negative for x, this is positive for x this side. Down here is negative for y, up here is positive for y. Okay, so now let us make a table, because a table will make it so clear and easy to understand while resolving the vector. Okay, so let's begin with the force of 9 Newton, followed by 15 Newtons. The next force here we have here is 10 Newtons, then 12 Newtons. They are 4 in number. So let's have the total here. Okay, now from here, the force of 9 Newton for the horizontal component. Remember, horizontal component deals with the cosine, while vertical component deals with the sine. I've discussed this in my previous video. You can check the link in the description to understand what I mean by the horizontal and vertical components properly. Okay, so for the 9 Newton force, the angle to which it is inclining at the horizontal is 90 degrees, because look at the force here. The whole angle here is 90 degrees, so it is inclined at 90 degrees to the horizontal. So I'll have it as 9 cos 90 degrees. And again, you ask yourself, should it be positive or negative? That's the question you need to ask yourself. Should it be positive or negative? It is neutral, in the sense that it is at the boundary of separation between the negative and the positive, and since it is neutral, we consider it as being a positive. So I will take it as positive 9. So cos 90 should be 0. Cos 90 is 0. So we'll have 9 times 0 is still 0. So this is 0. The next force we have here is 15 Newton. So we'll have 15 Newton for x is positive because it is at the right hand side. So we'll have 15 cos it is 60 degrees and inclined at 60 degrees to the horizontal, cos 60. Cos 60 is 0.5, and 0.5 times 15 will give us 7.5. The next one is 10 Newton, so we'll have 10 cos the angle is 30 degrees. It is inclined at 30 degrees to the horizontal, so we'll have 10 cos 30 degrees, and cos 30 is 0.866, then multiply by 10, 8.66. That is what it is giving us, 8.66. Remember, it is positive, it is still at the right. But the 12 Newton force is at the left. Then for the horizontal component, is going to be negative because it is falling at the left. So this will give us minus 12 cos the angle is 40 degrees. Cos 40 degrees. So minus 12 cos 40 degrees will give us minus 9.19. Minus 9.19. That is what is giving us. So let us go for the vertical component. So for vertical, we are using sine. So have 9. The 9 for y-axis vertical is negative because it's side down. So have it as minus 9 sine, the angle is 90 degrees. Sine 90 should be 1. Sine 90 is 1. Then 1 times minus 9 will give us minus 9. So have the next force is 15 Newton. So have 15 Newton is still at the down. So down is negative. So I have minus 15 sine 60. Sine 60 is 0.866. So 0.866 times negative 15, which I have minus 12.99. The next one is 10. The 10 is up, so it's positive. Positive. So I have 10 sine 30 degrees. Sine 30 is a half, and half times 10 should be 5. The next force is 12 sine 40 degrees. 12 is still positive, so it is plus. So 12 sine 40 will give us 7.71. Now, having resolved the forces according to the vertical and horizontal component, it is wise to find the total sum of forces here. So the total here will give us 0 plus 7.5 plus 8.66, then plus negative 9.19. This will give us 6.97. It is positive Newton. Then coming here, we'll have minus 9 plus negative 12.99 plus 5 plus 7.71 to give us minus 9.28 Newton. That is what is giving us. Then remember, resultant R is equal to square root of x component squared plus y component squared. So this will now give us the square root of 6.97 squared plus negative 9.28 squared. So at the end of the day, our resultant will give us square root of 6.97 squared will give us 48.5809 plus 9.28 squared will give us 86.1184. So if you sum up, plus 48.5809 to give us 134.6993. So finally, resultant will now be the square root. So my resultant R is now the square root of that value to give us 11.61 Newton to 2 decimal places. So this is just the resultant of all these forces. So having got the resultant of these forces, it is still wise to get the angle of inclination. So look at the two forces we've got, 6.97 and the minus 9.28. So to continue, let me clean here. So it is negative for y. Remember, this is our x is 6.97 Newton positive. While our y is minus 9.28 Newton. Okay, so how do we get positive and negative? For x, it is positive, it is this side. Then y is negative. Okay, so this is x positive because positive is at the right hand side. Assuming x is negative, I will make x to appear here. So this is where I'll have 6.97 Newton. While my y negative is down. If it is positive, I will make it up. Minus 9.28 Newton. So their resultant is this, which I have got as 11.61 Newton. So this is the angle of inclination theta, for instance, which is opposite over adjacent, tan. So to get the angle of inclination, I will just say tan theta, which is opposite, minus 9.28 over adjacent, which is 6.97. So I have 9.28 divided by 6.97. I will get minus 1.3314. So I'll continue from here. So theta will now be tan inverse of minus 1.3314. Theta will give me shift tan minus 1.3314. This is minus 53.09 degrees. Now my theta finally can still be 90 degrees minus 53.09 degrees. When I do that, my theta will give me 36.9 degrees towards the southeast direction. Okay, so if you've enjoyed what you've watched, kindly consider subscribing to my channel. It gives you notification whenever a new video is out. Thank you.